Okay, so the thing is, yesterday we will see like how we can configure the IP address on Cisco ASA firewall, right? I will tell you what is the meaning of name if. Name if means we are just defining some name to a particular interface, some logical name. Like if that interface is related to inside network, so we give the name if as inside. If that interface connected with the internet, so we give the name if as outside. Okay, we have a security level. Now you are like okay with this. What is the use of security level in Cisco ASA firewall? And after we define the IP address. So we define IP address because we want IP connectivity. Okay, so these are the like format of these commands. Interface, after that we give the interface name. Here we define the name if value. Name if is inside. Here we define the security level and the IP address and no set. Okay, so I actually already told you these things, like what is the meaning of this show running configuration. Okay, it basically gives all the configuration which we have done. Okay, what are the configuration available in my ASA? If we run this command, basically we can able to see that running configuration. Okay, like right now if I want to see my running configuration, I run this command, show running config, like ASA version, ASA host name. Okay, enable password detail. So enable password is in encrypted form. Okay, so if we set any password there, it basically ASA encrypt that in some other format. Okay, so this is like these are the interfaces. So this interface have the IP address. Okay, and the name and value as well. This one also having the IP address. Okay, so basically it gives all the running configuration which is available in ASA firewall right now. After that we also have one more command, show route. Okay, basically if we run that commands, it shows all the routing, all the details which is available in our routing table. Okay, command is very simple. I run this show route. So basically it show me my routing table. Okay, currently I am having only one route which is a connected route. So I will tell you what is the meaning of that connected. Connected means if we configure the IP address on our interface. So I have configured that IP address. Okay, I have configured not this interface. I have configured this IP address. Okay, 10.1.1.250 and the subnet was 255.258.258.0. Okay, so it is showing as a connected means that is the route which is directly connected with the ASA, and that is the subnet value. That is the net mask, and that is the subnet value, and that is the like 10.1.1.0 host. Okay. So if you want to see the routing details, we run this command. What is the meaning of routing? Anyone know what is the meaning of routing? What is the concept behind routing?
We use routing to connect from one network to another network.
Yeah. So routing means if you want to go from one place to another place, right? If you want to go from your home to your office, or let's suppose your college. Okay, so to reach that from your home to college, you have lots of route, right? To go there.
Yeah.
That means it's like routing. So similar concept also work here. Okay, let's suppose this is your PC. Let's suppose this is your PC. Okay, which is connected with the internet, okay, or ISP we can say, so like PC. After that you have like here you have a Google, okay, you also have a Facebook, you also have a like Gmail. So let's suppose these are also connected with the ISP, okay, every company connected with the ISP. Okay, so the thing is now your this PC want to go to, if like he is trying to access the Google page, okay. So basically what he do, that PC send this traffic towards the ISP, right, or towards the default gateway. This is the like ISP. After that what happens, he send that packet to ISP. That ISP have all the routes, okay. ISO ISP we just send this traffic towards the Google. So Google give the reply to ISP and ISP just send back the traffic towards the PC. Okay, so that is the meaning of routing. Actual, it basically provide a path, okay, to reach a particular destination. So in our case, the destination are the Google, Facebook, and Gmail. Okay, these servers, these company servers. So if I'll see in my topology, so like this is my inside system, okay, this is my system, okay. Let's suppose here we have a like Google, let's take an example, okay, and here we have a Facebook server, and here also we have a like any server, like any company name like Cisco, okay. What basically we do, this guy send traffic towards the default gateway, okay, because in this system we have configured one default gateway, right, yesterday, IP address of this interface, okay. And let's suppose, so this is our ASA which is connected with the ISP, okay. Maybe ISP also have some other routers there, okay. These are the like routers, okay. And maybe it is also like he is also connected by in this way, okay. So we have connected by like this. So maybe Google is connected through this one also. Like this Cisco have a two connection from two ISPs, okay, for redundancy purpose. Let's suppose these are the routers like R1, R2, R3, and R4. So what basically RPC send all traffic towards the firewall, okay. In firewall we also put one default route, okay, because the thing is our firewall also not aware about the IP address of these Google, Facebook, Gmail, because these are the companies, or these are the like web servers which are using the public IP address, right. So we don't know that all the public IP address, right. So what we put one default route on this firewall, right, like this 000, means if this firewall is not aware about the routing, like if this firewall not have a particular route for this destination, then what he do, basically all that kind of traffic he forwarded towards the default gateway only. So this router this ASA send this traffic towards the ISP, okay. After that what happens, the basically job of router to find out the shortest path, right, always. So basically maybe this is a router, or let's suppose this is also a router which is known as a ISP router, okay. So let's suppose to reach the Google, this is the shortest way. So this guy send traffic towards this router, this guy send towards this R2, and R2 send the traffic towards the Google, okay. Like to reach the Cisco, we have like three ways. We have a two ways. We can go like this way, after this, and we have a like this is the shortest way to reach Cisco, right. So he sent traffic towards this guy, and he sent over traffic towards the Cisco, okay. So that is the meaning of routing, okay. Now I think all of clear with the routing. So maybe you also have that routing and switching classes, there you like get to know, more details on that. So the objective of mine here, how we can basically configure the routes on our firewall and all our this inside PC and inside host, okay, to reach a particular destination.
So we have to configure routes on firewall as well?
Yeah, definitely. Without configuring the route on firewall, we can't reach anywhere, okay. See, the thing is, let's suppose, let me show you one practical here, okay, one small practical. So route, if I run this command, I am having only route to this network 10.1.1.0, right? Meaning of this one, this ASA able to reach the host which is available in this network only. So right now we have only 2 hosts in this network. So it is able to reach to these guys, okay? 10.1.1.100. This is IP address of this system. It is able to reach this guy, right? And the IP address of this guy is 101. Let me check the IP address if maybe I didn't save that configuration yesterday. Oh yeah, that's one. So let me configure the IP address on that system. First I give the host name like inside. After that I'll give the IP address. .1.1.101 and 255.255.255.0. Okay. If I'll check here, so if we want to see the routing table on router, we run this command, say IP route, okay. So here also we have one connected route only, right? So meaning of this route, this 10.1.1.0, basically this guy only able to reach all the host, which is all the like endpoint. Endpoint means all the devices which is available in this network only, okay. So if I ping from this one now, let me ping to my window PC. I am able to reach my window PC. Let me also try to ping my firewall. I am also able to ping my firewall, right? And if I'll try to ping from firewall, that will also work this time. It is also working, right? Because we have a route in our routing table. Okay. So let me also check if we want to check our IP address on our interface, we run this console interface IP belief in firewall. Okay. So we also configure the IP address on this interface, right? 10.2.250, which is our DMZ interface. So let me also configure the IP address on this router as well. I set the host name, which is my DMZ. And I set the IP address on that interface. Now set down IP address, which is 10.2.2.100.255.255.255.0. So if I run that here, if I want to check my routing details here, so I run this one, so IP route. Now this network also have a route, right? 10.2.2.0. Okay. So I want to ping anywhere. It is basically now reachable to this guy as well. And also one more thing. This interface of firewall and this interface of the router, these are directly connected, right? So they have a like same IP address on same subnet, because this is a subnet which is 10.2.2.0/24, means here we have around 256 IP addresses, right? So this guy have 100 and this guy have a 250. Okay, so that is also like requirement. Both the end having must be have a same IP address. Okay, same subnet IP address. Now if I check my ASA again, so route, let me check my interface giga geo/2. Okay, so let me try to shut down and set back again. 10.2.2.250. So I'm also not having the route for that interface. So if I try to ping that interface, see, I'm not having route for that particular IP address, right? Actually, the thing is that is a weird behavior, because that interface I already put in a set state. Why it is not coming? So interface IP. Okay, that interface is already showing here up, right? So what I'll do, I need to reload this ASA once. Okay, right, ma'am. Because maybe I actually do some changes today, so that's why actually it is not showing. Let me stop this guy. Let me also go to here, write memory, and stop as well, because I have deleted and now I'll just reconnect. Okay, when you reconnect, you just start. I will take one lecture. Maybe tomorrow I will show you how we can install these softwares. Okay, so you can start your labs, because after that you have like Saturday and Sundays, so you can complete like this, complete the installation of the software maybe in that weekends. After that you have that software with you, so you can start your labs. Okay, so when you do any labs, you just follow my video. Okay, don't miss anything. Just first time you just pause the video and configure the things according to that videos. Okay, so the thing is, what is the meaning of default gateway? Default gateway.
Default gateway is like suppose local area network from any host, if they want to connect to the internet, first it will go to default gateway, and from the default gateway it will try to figure it out like where should be the shortest path. So it will, depending upon the routing protocol, it forwards the packet.
Okay, cool. So the thing is, everyone have a default gateway, right? Default gateway means if we set a default gateway here like 10.1.1.250, like that is the right default gateway, okay, to this guy. So if he get any traffic, he just directly send to us the ASA. Okay, so I have basically I'll done that same thing here. Let me show you the meaning of this guy. So I'll just open this firewall. I run this ipconfig. Okay, so here I'll set the default gateway 10.1.1.250, which is the IP address of my firewall. Okay, so when you run this command route print here, it is also like giving us the routing table in system. Okay, so that is the command how we can see the routing table in system. You are able to see this one, right? Let me go a little bit up. We have a like this default gateway, right? 10.0, sorry, 0.0.0.0.000, and the gateway is this one. Means this is a next hop. Okay, so this is the like same route. Okay, so that's why because this have a like this setting here, that's why basically it sends all the traffic to this guy only. Okay, so if I change the default gateway, okay, so let me change my default gateway. Yeah, I will just go there, because you always put one default gateway in your firewall. That's why actually I am putting more. I am just concentrating more on that. 101. Okay, so I'll have put the default gateway as 101. If I'll again check my route print here, now IP change, right? Now it become 10.1.1.101. Okay, so let's suppose if I'll initiate a ping, okay, to any public IP address, like we have a 8.8.8.8. That is a public, that is a like IP address, any which is IP address of Google. I'll use this -T to initiate a continuous ping. Okay. So now this guy basically sending all the traffic to us, this system. Okay. If I'll go in this system, and how we can verify receiving the traffic? We just debug the ICMP packets. Debug IP ICMP. See, I'm getting these packets, right? This is the IP address of my Windows system. This is trying to reach this destination. This is a destination, right? What happened here? Basically, this router is not having any routes. Okay. Debugging means we are just like seeing if our device receiving that kind of packets or not. Okay. Debugging means if this guy is try to send some packets towards this host. Okay. So if I enable the debugging on this host, so it shows me the real-time traffic. Okay. It is getting that traffic or not. Generally, we don't use debugging in production. Okay. This is a labs, that's why I'm using, because it's like very resource intense. It takes like lots of resources. Okay, so like it is not, we can't run debugging in real.
So like debugging, what does it do actually?
See, the thing is, it basically help us in a troubleshooting. Okay, suppose the thing is, this guy is not sending any, like this guy try to send the traffic towards this host. Okay, this guy sent to traffic towards this host. Okay, and something happened with this interface, like here with this device. It is not like, it is dropping that packets here only. Okay, and it is not receiving that any packets. So that in that cases we run the debugging to see we are getting that packets or not. Okay, so that's why we use debugging. Okay, to see we are getting the actual traffic or not. So here basically what happens, if I put the default gateway of this IP address, that is a like right thing. Okay, because this is a firewall which have a internet connectivity, right? So this guy send the traffic towards this firewall, and this firewall send traffic towards the internet. So let me now again go to my system here. Let me again open my network sharing center, and here I just change the IP address, which is, so here I put my firewall IP address. Means you can say we are setting the default gateway, or we are also like adding a default route. Okay, it is like both things are similar here. Okay, now I have a default route towards my firewall. Okay, if you see here. So now all of you are clear with the default, like default gateway. What is the meaning of default gateway in Windows system, right? So now let me go into my firewall. Enable, I put my password here, and let me check my routing table now. So route. So interface IP brief 0/2. Why it is not? Default is not working. Interface giga 0/2. Shut down. Shut.
Sir, the audio and video both are not working simultaneously.
Really? In
Yeah.
these two classes?
There is a lot of like, latency. What is it called? Time gap.
Oh.
Yeah. Suppose if sometimes you're trying to show something, that display is not coming. It's still on the same page.
Okay.
When you try to explain it. Yeah.
Okay, so I will try to use another like video recording tool from tomorrow. Okay, I will try to use Zoom. Actually, I like Zoom, but the thing is, it required a subscription. So maybe I will check with that Santosh if he allow me to do that. Okay, let's see. Otherwise, I'll just install that Zoom in my system and I record that videos here only. Okay. So IP interface brief. That's weird. See, the thing is here, it has like interface in up state, but the thing is, I'm not able to see the routing here for these interface. That's not it's a weird behavior. Okay, you can't see. Maybe I have problem with VMs. Okay, these things. So no worries. Let me just configure the IP address in my outside interface. Okay, so this is my outside interface. And the thing is, this interface also connected with the internet. Okay, so I am able to ping everything like Facebook, Google from my firewall only. I have done some configuration over there. So like when this is initiate any traffic, it's basically goes towards my Wi-Fi modem, and after that my Wi-Fi modem send this traffic towards the servers. Okay, so how I can configure the IP address in my outside interface? It is like very simple. I'll just go to in my interface 0/0. I run the no shutdown. Just name it. This is outside. Name is like very important. You have to like give some descriptive name always. Okay. Security level is 0. Always like make a habit of like writing the security level. Okay. And the IP address, which is 192.168.1.255.0.255.255.255.0. So route. Now I have one more route, right? Put this network. If I see my IP configuration, so IP interface believe I'm having this configuration, right? So I have a default network. That interface is not working properly. I hope that's why. Okay. Otherwise, we also see this network here only. Okay, in routing table. So we have a like IP routes for these two particular interfaces. So if I ping my Wi-Fi modem, I am able to ping 192.168.1.1. I will do ping my Wi-Fi. Okay. If I try to ping Google, that is a public IP address of Google, right? See, it is getting this message, right? We don't have route for this Google. Okay. So now what I'll do, I'll add a default route here. Okay. So how we can add the default route in firewall route outside, and in destination we get the all 0, 0, 0, and the next which is the IP address of my default router. Okay. Now if I check my routing, I have one default route, right? This is pointing towards my outside interface, and this is a next hop. What is the meaning of this route? Means if ASA sends any traffic, okay, which is not belongs to this subnet or this subnet, it basically sends this traffic towards the by using this default gateway, and the next hop for this traffic is 192.168.1.1. Okay, remember this thing. So like if I try to ping now Google, so the thing is I am not having any routes for this, right, as a connected here. So by default is use the default route ASA to send these packet towards the destination. Now I am able to reach, okay, to Google. Now let me show you one more thing here. If I try to ping the Google like this, it is not working. Like means it is like giving us this invalid host name. Same thing with the Facebook also. www.facebook.com. What is the meaning of this? Invalid host means it is not able to resolve the host name. Like it is not resolve this host name, which is like which point towards which IP address. Means here it is not able to resolve the name to IP. Resolution is not working. Okay. So in maybe sometimes you also need to configure these DNS details, right? Because DNS is a protocol which is responsible for resolving the name to IP address. Okay, like every website have a particular name like Facebook, Google, Gmail, but they also have a IP addresses. Okay, so the thing is how basically our system resolve these name to IP. They use a DNS. Okay, DNS protocol. So how we can configure the DNS thing in our system, in our firewall? So how we generally first configure the domain name. So in my case, I'll just give my domain name. Okay. After that, I'll configure my DNS. I give the name server. If you have a local DNS, okay. In organization, generally people have a local DNS, so they give here that IP address. I'm using here public DNS. Okay. So when you going to configure this thing, you may get this error. Okay. So DNS, after that you just give this command. Okay, outside. DNS domain lookup outside means the meaning of this command is when basically we are trying to ping any particular website by using his name, that time through which interface basically ASA need to send that traffic towards the DNS server here. So we need to also define from which interface basically ASA use to reach that particular DNS server. Okay, so I am using the public DNS server, so I am using my outside interface. Okay, and I'll just now run this command. So we need to run 3 commands. Okay, first one is the domain name. After that we define the DNS domain lookup and the if like what happens sometime, this is a firewall, you have like one DNS server in which is available in your DMZ zone or in your inside zone. So you need to define that time inside interface, or either is the DMZ interface. Okay, it depends on your organization where they have a DNS server.
So first we have to give the domain name.
Yeah, domain name is a like.
And then.
Yeah. Go on.
Yeah, and the second thing is DNS server name. What server we want to use.
Yeah. No, first command is a DNS domain. First command is a domain name. Second one is a domain lookup. Lookup means basically where he send that particular thing. Okay. Basically, so in our case we are using public DNS, right? Because we are not having any particular DNS server in our topology here right now. Okay. So basically now the thing is, it also need to, because the thing is when he create a packet for DNS, let's suppose from ASA, let's suppose I want to send some traffic towards the DNS server. Like in ASA, if I try to ping that website www.f5.com. Okay, so this ASA create a packet. How basically he create a packet? He just create a packet he create one DNS request packet. Okay, so here he put the source address of the outside interface. In our case, because we are using the outside interface. Okay, 250. After that we define name server, right? So name some server is a 8.8.8.8. This is the actual IP address of our DNS server. Okay, and here he put like he basically in DNS header, basically he want to resolve that website www.facebook.com. Okay, here basically he also include lots of things, because DNS basically work on UDP port number 53, right? So it also put like source port, destination port. So basically this is a like DNS header. I am basically focusing towards the IP header only and the things which is available here. Okay, and basically when he just ASA create this packet and send this packet towards the name server, which is 8.8.8.8. that server basically checks this packet. Oh, he want a IP address for www.facebook.com. So basically this DNS server have all the entries. Okay, like Facebook, for Facebook, Google, everything. Okay, this have all the entries. Okay, so basically now he basically he create the same packet. Okay, and he put the IP address of that Facebook. So basically when he ASA receive this packet, and basically he see inside this packet, okay, that this is the IP address. After that basically ASA create a ping packet, and he just ping towards this firewall. Okay, so let's suppose IP address of Facebook is a like 1.1.1.1. I'm taking this example. So when ASA create a packet, so basically he create this packet like this: 192.168 1.250. Okay, and one dot. This is a destination. This is a source. This is a destination IP. This is a source IP. Okay. After that, here he put the ICMP header. Okay, and basically send towards the Facebook. Now basically let's suppose this is a Facebook. It is available here. Okay, so Facebook received this ICMP request. He just give the reply back. So that is the process. That is the packet flow. Okay, for that thing. So now we have configured the DNS detail over there, right? So now if in this time I'll just try to ping Facebook. I will to ping Facebook now, right? And this is the IP address of Facebook, the public IP address of Facebook. Okay. If I want to ping any like gmail.com, this is the public IP of Gmail, and I am also getting the ping. Okay. That means like if you get these signs, okay, this means ping is working. Sometimes there is a loss, there is any packet loss, that time you get the question mark here. Okay. So ping is working properly. That's the way. If I can also able to ping that Google now, www.google.com. So this is the IP address of Google, actual IP address of google.com. Okay. You see, every company have a lots of IP address. Like if I'll try to search here, facebook.com IP addresses. Got anything? The Facebook have around 7 on, not this one. It is opening my Facebook here. There is one website IP mango.com. So if you want to check the IP address of any website, okay, you can go from here. So just you click on IP who is, okay. Actually, this gives like information regarding a particular, if you put IP address here, let's suppose put this 10 dot, not 10, 100 dot something, 5.6.7. So basically it is like giving me that much details, okay. This is the IP address, okay, all the details, parent name, company name, everything. If you want to see the IP of a particular website, actually there is also something. We can also put the name of that particular website. After that we get the, let me go into the location. It is not, I think. There is also lots of website available like this. If you want to see the IP address of particular websites, you can just put that the URL of that particular website. They will give you the IP details. Okay. IP address of Facebook. If I Google it, maybe I'll get, see, these must IP addresses using by the Facebook. Okay. These are used. If I'll try to see the IP address of Gmail, okay, so you can Google it, these things easily, and you got all the IP address which is using by these servers. Okay. So like this, you all like Cisco IP address of Cisco. So like these are not that is not a correct one. So Cisco have lots of things there. Let me try to see my college website IP address, hs.ac.in. If I getting the website, not that particular thing. Okay, so that is the way how you can find the IP address. Okay, there is also some regional directories available. Okay, because I now have divided something there. Okay, like this IP address is also getting lots of details. Like www.vietjhs.ac.in. So like this is IP address of my college website. Okay. Now if you want to see the IP address of Facebook, let me try here. So maybe Facebook uses around 4-5 IP address. So this is the IP. This is the one IP address which is available in Ireland. Okay. So you can basically get these details from here. Like this is the IP address for this particular URL, www.fbcdn.net or www.fb.com is using these much IP address. Like they have around 20 to 256 IP addresses there. Okay. Because the thing is every organization use the dynamically changeable IP address. Okay, because that prevents from the happening of some attacks. Okay, if IP address change every 2 seconds or every seconds, in that cases they will prevent the particular they just try to prevent the particular identity of a server. Okay, so now you got the idea what is the default gateway, right? Or you need like some more explanation on particular on that? So if we have a route, then only we are able to reach this particular these websites. If I remove this route, okay, no route outside 00. So here I also need to define my next route. That is the way how you can remove the route. Okay. So route. Now I am not having any default route. Okay. If this time if I try to ping that google.com, ping will not work because we are not having any particular route. Okay. So we need a route to send the traffic to us any particular website. So we have a default route now. I have just put the default route. If I try to ping, I can able to reach Google. Okay, because I have a default route here. So that is the meaning of default route. Or in every organization, we have a default route which is pointing towards the outside interface. Okay. Now let me tell you one more thing. Let's suppose we are also having some more routes like 10.1.2.0/24, 10.1.3.0/24. These two networks. Let's suppose we are also having some other switches here. Okay, like we have two switches here, and which are connected by using these IP addresses. Let's suppose these are the L3 switches. Okay. So I'll basically configure the loopback interfaces on my router now to show you like how I can basically show you these routes. Okay, there. So right now I am only having IP interface wave. I am having only this interface which is having this IP address. Okay, and this is my routing table. So IP route. This is my routing table. Okay. So now let me advertise these two networks as well in this router. I'll just create a loopback interface here. IP address. I define the 10.3.100.255.255.255.0 and let me add one more loopback. This is a loopback one. Okay. So you can either use a full command here, okay, like interface loopback one, or you can either use this one. Both will work. Okay, L then one. So here I define the IP address which is 10.1.3.100.255.255.255.0 and set down. If I check my routing details here, IP configuration, I have these two interfaces as well. These are the loopback interfaces. Okay. So IP route. Now I am having these two routes also. 10.1.1.2.0 and 10.1.1.3.0. Okay, these two networks. If I ping this network from here, I can ping 2.100 because these are available in this system only. Okay. Let me disable the debugger. I will to use this one. I am also able to use this one. Now, if I'll go into my ASA firewall? So, now you are not able to see these two routes in the ASA, right? So what happens here? We are only having the default route. Okay. So if I initiate that traffic to these guys 2.100, which is available in my inside network. Okay. ASA basically send this traffic towards the default gateway only. It is like trying to send this traffic towards the default gateway. So what we need to do now? We need to tell this ASA firewall, if you want to reach this network 10.1.2.0 and 10.1.3.0, you have to send this. If you want to reach this network, you just send this data towards the router interface F0/0. Okay, and after that router basically send this data towards these network. Okay. So that is the like static route. How we can configure the static route. Now I am adding some static route on my firewall. How I can do? It's like very simple. Route. After that, I'll define my name of my inside interface because that route available in my inside network. There I define inside. Okay. After that, I'll just define the host name or network of this particular IP address, like 10.2.0. This is the network. Okay. And the subnet mask 255.255.255.0 and the next hop. So basically next hop for this window PC is the this IP address like giga0/1. So the thing is, if this ASA try to send some traffic towards these networks, so next hop is the IP address of this interface, which is configured in my this router. Okay, so what is the IP address of this router, which is 100? So IP interface brief. IP address is a 10.1.1.101.100. Okay, so I'll just put the next hop as 10.1.1.101. I have added this network. If I try to ping this guy 10.1.2.100, I can able to ping, right? If you want to cross verify this thing is working, you just name the debug IP ICMP. If someone try to initiate ICMP traffic, or if this router receives any ICMP traffic, it gives that logging information there. Thing is working, it is like also giving us that information, right? It is debugging information here. Now what about this network? What I need to do for this network to provide the connectivity from ASA to this network. How I can provide that connectivity, guys? Tell me anyone. This is my routing table. So route. I have one route for this network 10.1.1.2.0. Okay. So this network also available in same place, right? So I need to add one static route for this network as well. How I do that? I'll just use the same code route after I define my inside interface and the network of this particular network 3.0 and the subnet mask 255.255.255.0 and the IP of this interface. Okay. 10.1.1.2.0. 1.1.101. Then route. So what is the meaning of this right now? If ASA receives any traffic for this network 10.1.1.2.0, okay, he basically send this traffic to this guy, this IP address through inside interface. Okay, that is the meaning of these things. So if I now try to ping will work 10.1.3.100. I will ping this guy also. Okay. So here I am also getting the debugging. So like that is the way how you can configure the routing and all, how you can add the static routes. Okay. So any doubt on static route configuration, or what is the static route, what is the default route, default router, what is the default gateway? Do you have any doubt on that, or all of you are clear with this?
So route inside we use for local area network, route outside we use for outside area network.
Yeah, definitely.
Okay.
Okay, because we have this inside network here. Okay, so let me also introduce few more network. Okay, let me create a loopback interface, loopback like to IP address of. Let's suppose we are also having this network in our insides. Okay, somewhere else 1.100 255.255.255.0. Okay, after that let me add one more network. Like here I'll use this 2. Okay, IP. So I have got these two network as well here. Okay, in this router, these two network. Okay, if I'll check my interface configuration, so IP interface brief, I'm having these IP address on these particular interfaces. Okay, so what I need to do now, I again add two more routes on ASA firewall to get the information of these two networks, these two new network. Okay, so I'll just go to in my firewall. I use the same command route inside 172.16.1.0 255.255.255.0 and the 10.1.1. This is my next hop IP address of this particular interface. Okay, same for another one. I have added two route. If I check my routing table, I have these routes. Okay, so now I'll got these two routes also in my interface, right? So if I try to ping we use for checking the connectivity. Okay, 172.16.1.100. I will to reach this network and this network as well. Okay, so that is the way how we can add a static route. Okay, always.
So in local area network, we can have like different kind of IP address, like 172.16.2.2 or like 192.168.10.10.
Yeah, let me tell you, I'll just try to explain one topology over there. Okay, so what kind of topology we have in every network having this kind of situations. Okay, so this is a ASA firewall. Okay, so let's suppose not ASA, I'm not going with the particular, this is a firewall. Okay, this firewall have a connection with the internet, which is known as ISP. Okay, after that here we have a router. Okay, which is known as a core router or L3 switch. So L3 switch means it is also able to do the switching, the routing capabilities. Okay, So this basically router have a connectivity with the switches. Okay, so like let's suppose this is your switch 1, this is your switch 2, okay, this is your switch 3. You have around 100 of switches, like you have a 10 switch till switch 10. Okay, so they all have connectivity with this router. So let's suppose this switch having a VLAN 10. Okay, and the subnet of VLAN 10 is 10.1.1.0/24. This switch related to VLAN 20, and the subnet is 10.1.2.0/24. This is like VLAN 30, 10.1.3.0/24. Okay, let's suppose this is a switch 10 which is using VLAN 100, and the IP address is 10.1.1.10.100.0/24. Okay, so what you do now, you have to configure the static routing on this guy, on firewall. Okay, you have to configure the static route for these particular networks. Okay, these all networks which is available here. Like for these networks which is available in your inside network. Okay, and what you do, like these are the switches which from where your actual PC is connected. Okay, like PC1, PC2, same thing. Like this is a PC3, like this. This is a actual network which you have in a particular organization. Okay, so you have to put a static routing for telling the firewall, if firewall try to these networks, basically he just send this traffic towards this guy router, that router send this towards this traffic towards the particular destination. Okay, and in this firewall you also need to configure a default route. Okay, which is 0.0.0/0, means for any network other than these networks, if firewall got any traffic, basically send this traffic towards the ISP. That is the meaning of default route. Okay, so the thing is, the static route have a higher precedent over default route. Okay, so let me giving you one example here for the similar thing. Okay, if I'll go into my firewall, let me disable these things. So the thing is, I am not having any route, right, for this guy. Right now, or this guy, 10.4.4.4. This I am not having any route for these guys, right? So these guys basically reachable via default route only, and these are the public IP address which is available publicly somewhere else. If I add any static route inside, like for this network 4.2.2.2, for this particular IP address, I can also add the route like this. Okay, after that I'll define my 101. That is the IP address my firewall. Now if I try to ping 10 this guy with a repeat count of 10. So basically now ASA try to send 10 ICMP request packet towards this host. If I go to my... The thing is now what ASA is doing. ASA is sending this traffic towards the inside router. Like he is basically sending this traffic towards this guy only, because I put the static route. So the thing is, static route have a higher priority than default route. Okay, remember this thing. So that is the like verification for us here. Okay, so let me remove this route because this network available in outside somewhere else. Okay. If I'll remove this route if I try to ping, nothing is succeeded. That time ping is not succeeded because that network is not available. Like this IP is not available in our inside network anywhere. Okay.
So like I have one question for this window PC, why the router is on another, this is a switch, this net one.
This is a switch, right?
So why the router is on the like other side? It should be before firewall, correct?
No. What happens? People always, the thing is when you got any router from the internet, okay? That is a very small kind of router, okay? If you have a like internet connection in your home, you get one router, right? So it's basically it is a like device which is able to do the routing as well as bridging, or you can be in other word it is like switching. Okay, so it's not like intelligent routers. It's a like switch, like that power switch. If he get any traffic from in this interface, he just forward through other interface. That's it. That is the working of this particular router. It's not actual router. These are the like intelligence routers where we configure the routing, where we can just configure the routing according to us, where we want to send that particular traffic, right? Okay. And also one more thing, there is some scenario where we put one router sometime in this place also. Okay, so I'll tell you that scenario. So let's suppose.
So we will be having an IP address for the different IP address for router, different IP address for switch. And firewall. Correct?
Yeah, different. We need a different IP address in that case, because the thing is, in router interface, we always need to put a different subnet IP address on two interface. We can't have a same subnet IP address on two interface. Okay.
So we need two IP address, one for firewall, one for router.
Yes. So like this is my router. Okay. So IP interface brief. So let's suppose I am having this IP address in my interface. Okay, if I'll try to configure the same subnet IP address on my another interface, which is Ethernet 0/1 fast Ethernet IP address, it gives me it basically through one error. Okay, 10.1.1. Let's suppose I'll use here 200. Okay, 1.200 255 255.255.0. See, it overlap with this interface. Okay, I'm getting this error. So means in router interface, we need to configure the different subnet IP address always. Okay. That same thing also applicable on firewall. In firewall interface also, we don't have a like same subnet IP address on two interface. Okay. So I'm here. Okay. So like let's suppose you have a ASA firewall, or let's suppose you have any firewall. Okay, not ASA. Let me select my. So this is my firewall. Okay. And this firewall have a connectivity with the router. Okay, so these are the router which are the CSR series router or ASR series router. These are the very high-end routers. Okay, these having around very very high level of throughput. Maybe like in every interface of these routers, these are the like around 40 Gbps. Okay, that much throughput these interfaces having for these routers. Okay, so what happens, sometimes you have that kind of scenarios. This is your ISP. Okay, like this is your ISP1. After that we have ISP2 for redundancy. Okay, and we also have a one MPLS backbone. These are the very high level overview MPLS network. Okay, and let's suppose this is your branch office.
Sir, what is this MPLS network?
See, these are the like layer 2 technologies. Okay.
Okay.
So these are the part of switching, man. So in switching classes, you get like very good idea of this MPLS and other steps. Okay. I'm just telling you the what kind of scenario we have in real network. Okay. Every big organization having that kind of scenarios. Okay. So they have a two ISP links. Okay. This is like primary. Another one is secondary. Okay. They have a MPLS. So basically it's like very costly solution. Because what happens in that costly solution, that ISP, it's also like a kind of ISP, but ISP basically gives you a one lease line. Okay, lease line means they just give you one dedicated line. Okay, so let's suppose this is your head office. You have several branch offices, like you have a branch office 2 here. This is a branch office 1. So they basically also provide a connectivity to your branch offices. So like the thing is, now if you have a users in these this office, okay, in head office, these are the like users, and here also you have some users. So what happens now? These users basically consider these branch office firewall as a like they are connected locally. Okay, they are not these users, and these users are not available. These aware about these MPLS links. They have any MPLS kind of solution here. Okay, they basically consider as a they are locally connected. That is that kind of basically scenario that kind of basically scalability we got with by using MPLS kind of solutions. Okay, so sometime also what happens, we have a like one firewall, we have a another firewall like this is a firewall 2. Okay, these both firewall connect with a switch here. Okay, and that switch connect with the ISPs, ISP 1, ISP 2. Okay, after that you have a like internet, like this is your core switch. Okay, this is a L3 switch. You also have that kind of solutions as in organization. So the thing is, both firewall do the forwarding. They may be running in an active standby mode. Like it's like high availability concepts. Okay. High availability means if this firewall goes down, at least we have another firewall to do the forwarding. If this firewall goes down, we have this firewall too for the doing that forwarding of traffic. Okay. So that kind of scenarios we also have. And nowadays basically no one using these. So that legacy switching technologies. Okay. Everyone using these network, these kind of scenarios, leaf and spine. They have a fabric. These are the like very high level. Okay, I just want to tell you like, what are the new things which are available in the market. Okay, so they have a like a spine switches, like a spine 1. They have a spine 2. Okay, after that they have a leaf switches, like leaf 1, leaf 2, leaf 3. Okay, they have like interconnectivity with each other. Okay, like this. And here basically actual end host is available, or maybe these are the like web servers. You know, like Facebook, everyone use Facebook, right? Nowadays, if we put like simple switch like 6500 switch or 37500 switch here, it basically able to handle only thousands of requests, right? But maybe in every second, Facebook may got a millions of requests, right? So how basically these kind of solution deployed? For that we use that kind of switching technology, leaf and spine architecture. These are the like this basically this whole thing is known as a fabric. Okay, so this is also a like fabric path. So people are using these kind of solutions now. But the thing is, you are like just freshers right now. So you need to know the basic things also. Okay, when you just become good with basics, then only you can move into these latest technologies, right? Because if you directly start learning these technology, you are not able to manage these things. Okay.
So I have one question. Can
Okay.
we directly connect ISP to our switch?
Yeah, directly. Generally, what happens? This is a like firewall. Okay, we can directly
Okay.
connect the ISP with the firewall itself. So every ISP gives us one like a small router kind of things, right?
Okay.
They gives us like one small kind of routers. Like in your home, if you have any Wi-Fi connection, they will give you that same Wi-Fi adapter, right? So that thing basically, so we connect our firewall interface with this side, and this have already a connectivity with the ISP. Okay, that is the like actual deployment of these things. Yeah. Okay. So now you are okay with what is the use of default route and static route, right?
Yes.
Okay. So guys, let me also try to show you some more thing. Okay, how we can configure our management interface. Okay, and how we can configure the telnet and SSH service over there, because I already show you that practicals on telnet and SSH yesterday, right? With the inside interface. Now we will, because the thing is we use always management interface to doing that kind of things. Okay, so let me go into my firewall. I'll just go into my management interface. I just run this command, no sir. Name if I give mgnt means management. In management interface we also define the same security level, which is 100. Okay, and the IP address, which is IP address is 192.168.137. Let's suppose I want to give this triple one 255 255 255.0. Note it down. So interface IP brief. I have configured this IP address in my management. Let me try to ping. If I able to ping my 192.168, the default gateway for management interface 137.1. Ping is not working. Okay. Let me try to ping from my actual system 192.168.137.111. Yeah, I am able to ping from here. Okay, from here ping is not working because due to in my system I have antivirus. Okay, so actually let me disable this one for a minute. If I'll try now, it is not working. Okay, but I have a like connectivity from this end, so that is enough. Okay, let me enable, because otherwise, because due to window firewall sometimes he block the connection, like from that he block the incoming connection. Okay, it's like outgoing connection. He is like that connection is initiated from our system to other guy, that's why it is allowing. Okay, so now let me enable the telnet here. Telnet is management interface. Telnet, I will just use all the network. Okay, 00 means anyone can telnet management. So then let me see my typical configuration. So I am already having some triple related config here. So now this time if I try to telnet 192.168.137.111. Okay, let me use putty. Always use putty, okay, to do the telnet and SSH. 192.168.137.111. That is the way how we can configure telnet service in management interface. Okay. Let me see. Oh, sorry. Actually, I'm using here wrong IP. That's why. Let me reopen my putty again and try to tell it 192.168.137.111. This time I'll definitely get. I'm getting right. Cisco. I got the firewall. Okay. So that is the way how you can configure the telnet in management interface. Now let me also configure my SHS now. So SHS 00 management. Now let me open new session here. 192.168.137.111. Cisco. I'll get the SHS also. Okay. So that is the way how you can configure the SHS in telnet in management interface. Okay. Okay, guys. So now we will continue tomorrow. Tomorrow we will see some other things like how we can configure the routing protocols like VIP, EAGRP, OSPF on ASA firewall. Okay. If you have any doubt till now with the static default route, just ask me. Otherwise, I'll just end that meeting.
Sir, I have one question.
Yeah, tell me.
Suppose if there is any traffic is coming, and we have put like security level 50. Suppose if they denied that important traffic, so like it will get loose. So how does that firewall recognize whether this packet should forward or not to local area network?
Okay, so let's suppose we are like someone initiating some traffic from outside, okay, towards the DMZ.
Yeah.
Okay. So the thing is, we know what kind of services we are running in DMZ zone, right? Because we are the network guy. So the thing is, we just open the ACL on outside interface. Okay. These are my services which is running in my DMZ zone. If this firewall receives any kind of traffic on this interface related to these DMZ services, basically he just provide the access to these kind of services. Okay. Because we define that access. If you want to like provide all, you can also allow all the traffic. Like you just open one access list, like access list permit IP any. That means you are allowing all the traffic, so anyone can send any kind of traffic to your DMZ zone. Okay. So it depends on like how you want to configure the policies there.
So we can configure like security level 80 or